In our first lesson on expected value, we finished by writing down this formula for expected value. It's a rather intimidating looking formula. In this lesson, we're going to try and explain this formula by using it in some examples. And we'll see that in many situations, it's actually not that difficult to apply this formula. So what it says is that the expected value is the probability of the first outcome times the value of the first outcome plus the probability of the second outcome times the value of the second outcome, and so on through all the outcomes. The first thing to point out is that there's a nice shorthand for writing this down. So this is the same formula but written in a shorter way. So EV stands for expected value. And on the right hand side we have this nice shorthand for writing this long sum of terms. So we have the Greek letter capital sigma. This letter here is capital sigma, and in mathematics that very often is used as a shorthand for sum. And so what we're saying here is that we're taking the sum over all the outcomes of the probability of the outcome times the value of the outcome. So what this means is exactly the same as the formula up here. It means that we go through each outcome and we take its probability times its value, and then we add all of those things up, and that gives us the expected value. Okay, so that's the formula. It'll make a lot more sense when we see it in action in a particular example. So here's an example, and it's based on a device that you very often see on TV game shows, and that is the so-called Wheel of Fortune. So the idea here is that the Wheel of Fortune is essentially a spinner, and depending on where your wheel stops, you get one of the prizes that's listed in the sectors of the Wheel of Fortune. So in our example here, we have a Wheel of Fortune with 4 sectors of equal size, and the prizes are €100, €1,000, €10,000 and €100,000. And the question is, what is the expected value of your winnings? Okay, so let's see if we can apply our expected value formula to work this out. So the first thing is that we want to work out the probability of the various outcomes. So now in this example, all the outcomes are equally likely. So since there are 4 possible outcomes, that means that the probability of each outcome is 1 over 4. Remember that when the outcomes are equally likely, the probability of each outcome is 1 divided by the total number of outcomes. So in this case we have that the probability of winning €100 is 1 over 4. The probability of winning €1,000 is also 1 over 4. The probability of winning €10,000 is 1 over 4, and the probability of winning €100,000 is 1 over 4. These are the 4 equally likely outcomes. And now the values are clear. The values are the numbers that are given in each of the sectors. And so now we just have to apply our expected value formula. So the expected value, or EV for short, is the sum over all the outcomes of the probability of the outcome times the value. So what we do is we go through each outcome, we write down its probability, we multiply by the value, and then we add all those things up. So the first outcome is €100, that has probability a quarter, and the value is 100. Second outcome is €1,000, probability a quarter, value 1,000, and so on. The third outcome is €10,000, its probability is a quarter, and value is 10,000. And finally the fourth outcome is €100,000, its probability is a quarter, and its value is 100,000. And now we just have to calculate this, so you can use your calculator or you can do it in your head. And if you use your calculator, you'll find that this comes out to be, in euros, we get 27,775. So the expected value of your winnings in this game is €27,775. It's important to know what this means. What it means is that if you were to play this game many times, that in the long run your average winnings would be this number, 27,775. Now, before we finish, I want to make two important observations about expected value. And the first one is apparent in this example that we've just done. And so the first point is that the expected value is not necessarily even an outcome of the trial. And you can see that in this example here. The four outcomes were 100, 1,000, 10,000 and 100,000. And the expected value came out to be none of these. It was another value altogether. So no matter how many times we played this game, we would never win 27,775 in one particular playing of the game. That's not what expected value means. Expected value is the average value that we get when we play the game many times. So that's an important thing to realize. The expected value is not necessarily an outcome. And the second point is kind of related to the first one, and it is this, that sometimes the expected value happens to be one of the outcomes. That can happen in certain situations. But even when that happens, it's not necessarily the most likely outcome. So what this second point is really saying is that the word expected here is a little bit misleading. When we use the word expected in normal non-mathematical use, what we tend to mean is that it's the most likely outcome. But in this technical sense here, expected value is not necessarily the most likely outcome at all. And it's important to realize this, that the expected value is just what you expect the average to be in the long run.